Welcome to Study Loop.
This is the answer to Chapter 13, problem number 43 from the Smith Organic Chemistry textbook. And in this problem, we are asked to match 6 molecules that were given to the 6 IR spectra that were also given. So it's a matching problem. So match each molecule to its IR spectra. And so obviously I can't redraw these spectra. So what I've done is I've just listed the important peaks, the peaks above 1500 wave numbers. And so obviously I do want to point out each of these also is going to have the peaks between 3000 and 2850 wave numbers for a CsP3 carbon bound to a hydrogen. And so we can safely ignore that, right? Because if it's present everywhere, then it's essentially meaningless. It doesn't help us at all in differentiating between these molecules. So looking at spectrum 1, we have a carbon-carbon double bond that shows at 1650. And then we have the CsP2 hydrogen bond that shows at 3150. So the main feature of this molecule is going to be that it has a double bond in it. So if we look at the molecules that were given, we're looking for something where really its only feature is going to be a double bond. And so looks like B and C are our choices here. But of course, C, we're not really talking about double bonds. We're talking about a phenyl ring. And so there's going to be peaks at 1500 and 1600 for that. And we don't see that here. We just see the 1650 peak. So I'm going to go ahead and say that spectrum 1 corresponds to B. Okay, and so B is this. So CH2, C, CH3, CH2, 1, 2, 3, 1, 2, 3. Okay, and so that's spectrum 1. It corresponds to molecule B because really the only feature is the double bond. So then looking at spectrum 2, the only feature here is the alcohol. And so of the molecules that were given, F is really the only one that fulfills this. So 2 is going to be F because the only real functionality in there is the alcohol. And so F looks like this. Oops. So there are 3 of them. And then the OH. Okay, and so that's 2. 2 is F. So looking at 3, 3 really has no peaks of interest at all above 1500. And again, just disregarding the C sp3 H bonds that all of these molecules have. And so 3 is going to correspond to D. It's just an alkane. So 3 is going to be D. And the structure of D looks like this. So 2 CH3s. And so actually I was wrong. So D has an ether in it. But of course, the ether bond does not give rise to an IR signal. So it does have that ether functionality, but that's not gonna show by IR. And so that's all right. That's still the correct answer here. So that's spectrum 3 is D. So looking at spectrum 4, we have CsP2 H bonds, and we have the bonds that correspond to a phenyl ring at 1600 and 1500. So 4 is going to correspond to C. That's our molecule with a phenyl ring in it. And so C looks like this. CH CH3, 2. So that's C, spectrum number 4. And then 5 and 6 I've put here on a next page. So 5 is the major features of 5 are gonna be a very broad, wide OH stretch. So that right there is screaming carboxylic acid, and especially taken in conjunction with the carbon double bond oxygen at 1700. So this is going to definitely be A, our carboxylic acid. So molecule A for spectrum 5. And the molecule looks like this. Let's see, 1, 2, 3. Okay. COOH. So there we go. There's A. And so for 6, that really just leaves molecule E. And the main feature of molecule E, there's this ester. And so the only thing that we're really going to see is the carbon-oxygen double bond at about 1700. And so the molecule is going to look like this. Okay. Yeah, and so there's our ester with the carbon double bond oxygen stretch. And so that's how to approach this problem. I think identify what the peaks of interest in each spectrum are, and then look at the molecules and see which molecules have those peaks and only those peaks. And so if I were to, I solved this in order just for the sake of doing it in order. If I were to approach this problem, I would probably try to assign 3 first, since it's the easiest, since it has no real peaks. And then like 2, since it just has an alcohol, 6, since it just has a carbonyl, and then see what's left. 5 with the carbonyl and that very broad OH is pretty definitely a carboxylic acid. And then the other 2 are easy to distinguish between when you realize that the peaks at 1600 and 1500 correspond to the phenyl ring instead of just a regular double bond. And so that's the answer to chapter 13, problem number 43.